W6WH in California. Well, here we are overhauling an SB-200 or SB-220 Heathkit linear amplifier, and somebody had put a different relay in this thing, a 24-volt relay, and we're replacing it with the original. But in doing that, they had cut this piece of coax short and painted the end with dope, and so I've got to make a new one. Well, I'm the first to admit that I'm pretty dopey right now. I've been really sick for about a month, and so in trying to make these yesterday, I managed to screw up 3 of them. So I thought, well, there's got to be a better way. And part of the screw up came from trying to use different kinds of pens to mark the dimensions on here. It's a pretty simple cable, and the manual spells out how to make it. You're going to make an 1 7/8 inch removal of the outer jacket. You're going to have a 1/2 inch at the inside that's tinned, and you're going to have an 1/2 inch bare to connect to the relay or the connector, and in between you're just going to have some center insulator. Well, I tried this 2 or 3 times and managed to cut through the shield and break it, and managed to make the dimensions wrong, and just managed to screw up all kinds of things. So I slept on it overnight, and I decided, well, what can I do to keep from making these mistakes? And the first thing I did is abandon trying to use pens to mark this, and because you don't end up with a circle, you end up with one of these things around the jacket. So I used a couple of pieces of electrical tape, which gives me a nice straight edge, and then I was able to carefully cut that way. And rather than cutting all the way through the jacket until you feel the braid, just cut part way down and made sure that I scored all the way around, and then made a slit across this way. And then I took my dikes and grabbed that piece there where I'd made that split, and just literally pulled it off, and it's weakened enough by scoring it that it gives you a nice straight clean edge. So I'm going to do that on both ends, and that will eliminate the problem of accidentally cutting through the braid as I did here. I actually cut halfway through the braid, and that ruined that. So I put all the effort into doing one end, and before I had trimmed the other end and ruined it. So what I'm going to do is trim both of these, because this is kind of the classic place where you can really wreck the thing. And then the next step is I've got a little piece of emery cloth, because this is old coax. It's been lying around for a long time, and so I'm just taking and brightening up this copper a little bit, so that it will take solder more easily. Just getting a little bit of surface corrosion off of it, and then with my soldering iron, I'm putting lines of solder, probably 3 or 4 lines of solder around, and then I'll just take my soldering iron and distribute it around. You're just tinning this, and unfortunately this is foam insulation in the center instead of solid, so it melts more easily, so you really have to be careful. But anyway, I'll do both ends, And then I'll do the same thing and mark back a 1/2 inch from the end on each end, and cut right down through the braid, trying not to nick the center conductor and pull the ends off. I left a little bit of extra length on one end to get around to that relay. It's very tight back here in the PA, and you have to have these dimensions absolutely right. There's only one place this half clamp can go, and only so long this center conductor can be. There's a little more room for play over here, so I'm leaving myself a little longer center conductor to get to the relay, but I'm putting the tinned part where you ground the shield in exactly the right place, because there's a screw right there. That's a fixed position, and the relay position is fixed. So anyway, I think that trick will save it. And you know, it seems like a 12-year-old ought to be able to make one of these things, but I guess I was just dopey from being sick or just old, and screwed them up. So this should eliminate the screw-ups, and if you use this method, maybe you can get it in the first go. Okay, here I'm using benchmarks. I laid the dimensions out on the top of the workbench, and mark them with colored ballpoint, because it gives a nice fine line. It's very difficult using a measuring tape rather than a ruler. You get some ambiguity with the movable metal end, so I'm using a different part of the tape away from that metal end, and also because it's almost impossible to get the curve out of the coax. You have to hold it flat with one hand and mark with the other. So the benchmarks on the table work much better than trying to measure directly off of the tape, and I'm getting more accuracy this way, and using the electrical tape gives me cuts in exactly the right place and nice square ones. So those are the tricks that I'm developing to do this simple job. Okay, I guess you might as well go ahead and watch me do this. I'll screw it up or get it right, one or the other. So, use my benchmarks to establish the position of the tape. Got my razor blade still halfway sharp. And I'm going to score this, the cover of the coax, but I'm not going to get down until I feel the grit of the shield, because I do not want to score the shield and compromise it. And I would do the same on the other side. So I'm sliding the razor blade and rolling the coax at the same time, and using the straight edge of the tape as a guide. So there we go. Now, pick a convenient spot, and I'm going to cut this cover and try not to get down to the shield, but it's a deeper cut than the others were. And then I'm just going to find that place and grab it and peel this cover off, and where I've scored it, it's just coming right off. And so there I've got a pretty straight, clean kind of a cut and removal of that thing. I've got the same thing on both sides now, and I'm going to check with my benchmarks, double check everything's in just the right place. So you can choose at what point you want to tin these things. But I've been doing this with the cover on, and then cutting the shield later. I think because it keeps the end of this shield from flaring out. Having the cover over there keeps that shield compressed and keeps the ends from flying and making the thing fatter. You don't need a lot of solder on this thing. You don't need it to be a big lumpy mess. You want the clamp to go over it. So now what I'm going to do is take my emery cloth and try to make this shield brighter so it will take solder better. This got a little bit of surface corrosion on it. I don't know, this coax is kind of like a kitten. You don't really know where it's been. But so especially at this edge here where you're going to cut the shield after you've tinned it, you want to have a nice clean bright bit of copper there right at that edge, so that you get a good a nice clean result when you're done. So you can shoot that with contact cleaner if you think it's contaminated. It's nice to start with nice new clean coax, but this is what I pulled out of the junk box, which I think is actually perfectly decent coax. I just want to have a nice sanitary result here. Go to all this trouble to take an amplifier that was kind of a dog that had been, well, let's just say it had a golden screwdriver by an old timer. He was a friend of mine, so say anything really bad about him, but he was not the finest work I ever saw. And so we're just putting it back to original and trying to follow the manual. So there we go. I think it's going to be pretty hard to screw this up now. I've left some extra length on here, as you can see, so that I can have the center conductor be a little longer, and I can trim it to length. But all the other dimensions, these tin pieces have to land in exactly the right spot on the amplifier, as I showed you earlier. There's holes in the chassis, there's clamps there. They have to go right there, and it's laid out in such a way that that the amplifier works well. So you don't want to mess with that. So I think we're good here. Fire up the soldering iron. So we'll just turn this off until the iron warms up. Okay, so now if I were going to be soldering some PL259s on here, something I'd probably want to use a big soldering iron and try to do it as fast as I can and all that crap. This is not a typical soldering project. One of the biggest concerns here is to not apply too much heat and not melt the center conductor, and in this case it's foam, so it's even easier to melt. So make sure you got a nice clean iron. Contrary to the usual way of soldering, where you want to get your work real hot and then put the solder on there, I'm actually going to touch the solder to the tip and just try to get it deposited on here a little bit, and go and leave it and turn it around some more and do the same thing. Get a glob of it on there and turn around and leave it. And I'll show you why I'm going to do that in a minute. Otherwise you end up putting too much heat on here too long, and you'll make yourself a mess with the melted center insulation. And you want to try to preserve that relationship between the shield and the center conductor as much as you can, because that's really what determines the impedance of the cable. So now you should be able to see that I've got some blobs of solder on there, and I'm going to go around with my iron and melt them and try to smooth them out. And in the process of doing that, they're going to get hotter and bond better. But I'm paying attention to not overheating this thing any more than I have to. And you don't need a lot of solder on here. You're just creating a connection that won't corrode, that will be a pretty good mechanical connection to the clamp that's going to do the grounding of this cable at both ends. So there you go. Now, because that thing is hot, and the center foam in there is probably pretty hot, I'm going to just let it cool and not manipulate it, because I don't want that the center conductor to move around inside there. I want that foam, if it's gotten soft, to harden up and preserve that relationship between the shield and the center conductor pretty equally all around. Remember, there's going to be a 1.5 kilowatts of RF moving through this thing if the amp is running full tilt boogie. And if for some reason, like during tune-up, you're not working into an absolutely flat load, that RF voltage can get pretty high on there. And so you want this to be just as nice as you can get it. This one didn't get too hot, but I can feel the heat out here, you know, an inch or two away from the place I'm working. So I'm just going to let it sit for a while and not mess with it before I go do the other end. Maybe I'm being overly cautious, but what the heck, it doesn't cost anything to be cautious. So I'll turn this off while we wait. Now if we were going to be putting a connector on here, this wouldn't be too different. Tin the end of the shield before you put it inside the PL259, so that when you go to solder the connector, this is all tinned and it's going to solder up easily. So it wouldn't be that different, and the same considerations apply of letting this thing cool now before you do anything more with it. If you're going to put a connector on here, you'd be trimming this off and having the center connector come out, and a little bit of insulation in there so that it couldn't short out on the inside of the connector. And for all of that, you want the center insulation to be nice and cool, because you're going to heat it up yet again when you solder it. In this case, we won't. The only soldering we'll do is when we trim this off, and we'll have a ½ inch of wire sticking out, and we'll tin it, which will be very fast. But if we were going to be putting connectors on this, it would be pretty much the same story. Make sure I'm actually recording here. Yep. Okay, so this is cool enough. I can put my fingers on it. This is barely warm to the touch out here. We'll go to the other end, and we're going to do exactly the same thing. Put my glasses on so I can see what I'm doing. Clean soldering iron. Get plenty of solder on the tip there, and just deposit some solder on there, and work your way around. In at least 3 or 4 places you've got to do this, and I think 4 is probably the right number. Remember, you don't need a huge amount of solder on here. We're just tinning the surface of this thing so that it's mechanically stable for the clamp to clamp onto it, and also it helps keep it from oxidizing over time. So, alright, we got our 4 globs of solder on there, and now we're just going to take the iron and melt them, smooth them out, try to get them to bond to the braid, try to get them to be smooth. You do need an electrical bond to the braid, so it's got to get hot enough to really do that. No doubt about the fact that it got to get hot enough so that it's actually soldering. Okay, there we go. Not lumpy, well bonded, fairly hot there. It's almost too hot to touch. So too hot to touch is over 140 degrees. So you can feel the center conductor on the end, and the wire in the center conductor itself is so hot you almost don't want to touch it. So again, we're just going to let that sit for a few minutes. Okay, so there we've got a good result. Not lumpy. There's not excess of solder on there. We've got good clean edges here, so when we trim this, it's going to work okay. The other end is not quite as nice, but it's also going to be okay. So the next question is, how can we do the rest of the trimming of this thing to size without screwing it up? And I guess I'll let you watch me figure that out. Yeah, that's the end we just worked on, so we'll work on the colder end here. So Now what has to happen is that the cover comes off. Picture's worth 1,000 words. The cover comes off. We cut the shield so that we have this 1/2 inch of tin shield left, and the rest of the shield we remove. And at this end, we cut down through the insulation and have a 1/2 inch of the center conductor sticking out, which we tin. So now the question is, how are we going to cut through the shield without cutting the center conductor? And do we want to do it with the cover on or the cover off? And I think that I'm going to try to see. We have to leave the center insulator intact. We don't want to cut that up. We don't want to compromise that. And that ain't that easy. So I guess I'm just gonna try to cut around here as I roll and do this once or twice. And now I think I'm going to cut the jacket off and you can see what I'm actually doing. So let's see, let's zoom in on this a little bit. You can see what kind of an edge I got there. This is actually nicer than the ones I did before. That's a pretty nice edge, so if I can cut along there and have that be clean when I get done, I'm going to be a happy boy. See how it goes. Fairly boring watching somebody work at something like this, but you might as well see me struggle, because if you do it, you're going to see yourself struggle. I guarantee it. Alright. Now, so you can see what I'm doing. Going through here with my little dikes and cutting this off. And it may be a little crude. There's an understatement. It is crude, but get the bulk of it off here. Try to cut it back to the tinned part as much as I can. Get the bulk of this thing off of here, and then we can fancy it up. Well, okay, now you see I've got a couple of long strands on here that can short this thing out, but we'll try to go through here and nip this edge, get any loose crap that's left on there. Just melt it into the insulation a little bit. I really dislike these little slivers of shield. I want to get rid of them to make sure that we don't inadvertently have something we can't see shorten this thing out. Now I'm wearing magnifying glasses. These are prescription glasses with magnification, which really helps me see what I'm doing. If you don't have that, maybe you have to use something like a magnifying lamp, but you have to be able to see what you're doing. And of course, goes without saying that as you get older, this gets to be harder and harder. But I've been wearing those magnifying glasses since I was 40 and able to do this work. I couldn't do this work properly at 40 without the magnification. So there we go. I think that's a reasonable result. And we'll check it on our benchmark here if we haven't obliterated them all, which we pretty much have. And it'd be 1 7/8 inches long. So there we are. There's the 1 inch mark. 1 inch, 1 7/8 inches. That's just right. 1/2 inch of tinned shield, just like we want. So we'll trim this back 1/2 inch and tin that. And that'll be one end. So that's going to be perfect. So now, let's see what kind of a view I got. Can't remember how I have this camera set up. Back to wide angle here. So now I just have to repeat the process on the other end. I guess you don't need to see it a second time. Well, here's the second one. And just finished trimming that up, but I haven't managed to screw the cable up, so all I got to do is cut the ends and tin them, and this will be ready to go in the amplifier. So here's the 100-watt input cable for the SB-220 made in the same way.